everyone, it's your pal here. Just got in this morning. It's about 6 o'clock. I'm here to load your primers and your reagents onto our friend the robot. Doesn't look like much now, but after I get the code written right there, we'll see some magic. Hey everyone, now I'm just setting up the reagents. I'm going through the primers to find the ones that we need for the experiment. There are 6 total primers. Remember, there are 3 forward and 3 reverse primers, and these have been diluted to a concentration of 100 micromolar. So now I have to set up a concentration of 10 micromolar. Just got to find them first. This is my ice bucket. Some of the reagents are in here. Some of the reagents are over here. Defrosting, thawing, and when those are thawed, I'll put them on the ice bucket and then mix everything together. I'm calling this a master mix, and everything with the red check mark by it will get added to the master mix. So everything but the forward and the reverse primer, because remember, those were chosen by each of you, and those will be different for everyone. All right, we've got our master mix here ready to go. It's about 1 milliliter, which is mostly in agreement with what we have here. We've got our 6 primers, we've got our plate chilling, everything's good to go. Let's go set it up on the robot. Okay, I've got all the reagents on the deck, the program's running. We're both going to see for the first time how this works. There. Okay, so maybe it needs some optimization. But here it's dispensing, it should be dispensing 18 microliters of PCR master mix, and then to this PCR master mix we'll add each one of your primers. Alright, this is the reason I programmed the robot, and it's because it's taking 6 primers that are over here and figuring out in which wells to put the primer. So this would have taken me a long time to figure out, but thankfully with the robot I just tell it where the primers are and it kind of figures out the rest. So it's saving me some time. I mean, it took me a little while to program it. That's just because I'm not familiar with the interface, but I think in the long run this will be helpful. I just think it's amazing it knows where everything is. I'd get so confused. One thing it's also doing is it's getting a new tip in between the primers, and that's a good thing, because if there's just a little bit of primer contamination, it's possible that piece could amplify, or that amplicon could amplify, and it wouldn't be as pure. So when it fills up, and then after it fills up, it removes the tip in preparation for going into another well. Alright, run's finished. It took about altogether. Alright, run's finished. It took altogether about 11 minutes. Our plate's ready. It's been chilling on this aluminum plate, which has been pre-chilled on the ice. We're going to return it to the ice, and then we're going to put a seal on it. Alright, now I'm at a centrifuge, and we're going to spin the plates at 1,000 RPM, 1,000 G. Plate's going to go in there. Right, we got our PCR thermal cycler here. All the cycles set, temperature, annealing temperature, and extension temperature set. Putting the plate in here. Closing the lid. Telling it to start. Alrighty, here we go. My favorite part. Alright, I'm making the agarose gel, and I'm here in the agarose. I've got a certain amount. I want to get about 1.6 grams here. Just lightly dusting it. That's good enough. Just turn that. Okay, now I'm going to put this in TAE buffer and boil it. fun part of making the gel. It's about, using my fingers to feel it, it's about 55 degrees, which is about the temperature that we want. I'm going in for 10 microliters of ethidium bromide. And you see pulling it up, it is, how it's kind of red like that. I'm going to go in, I'm going to make contact with the surface here, and I'm going to dispense that 10 microliters of ethidium bromide. You can see it there at the bottom. And I'm just going to take it, swirl it around, make sure that it's mixed properly. I'm wondering if I should add another 10 microliters. No, I can see, you don't want to see it discolored, that's too much. I think 10 microliters will be satisfactory. And now I'm going to do something very satisfying. I'm going to take it, I'm going to pour it. This is 200 milliliters of liquefied agarose. And when it solidifies, it'll be an agarose gel. So that's when we make the pores that DNA can migrate through. Now I'm taking a whale here. This is called a comb. You can see combs come in different, well, I thought they came in different sizes, but this one only comes, sometimes these are wider to accommodate a larger sample. And this one isn't wider. So I'm going to take it and put, these are 40 well combs, put some there, put another one there. We should be good to go. We're just going to wait for it to solidify now. The agarose gel is firmed up. I probably shouldn't touch it without a gloved hand because there's ethidium bromide there, but it feels like a hard jello. So now we're going to take it and we're going to move it into the tank where there is TAE buffer. Okay. I'll move it from the frame. I need both my hands here. So you can see it's, whereas before it was liquid, now it's solidified, so it won't slide out. Now I'm putting it in a tank. This is TAE buffer, and it's specifically designed for an electrical current capacitor. Really, it's just water with a lot of salt. Okay, I'm going to add a little bit more buffer. Just want to make sure that surface is covered. Okay, now with a quick upward motion, I'm going to pull the comb from the gel. Hard to do with one hand when it's so long. 1, 2, and 3. Okay, now you can see the individual wells. It's into those wells that the samples will go. Okay, you got our wells. I've got a pipetter here. It's set to 20 microliters. I'm going to pick up a tip. Then I'm going to come over here. I'm going to aspirate about 3 microliters of 6X loading dye. You see that there at the bottom? I've got a big bubble there. And this 3 microliters I'm going to add to well 1 of the plate. So here's well 1. And I'm going to go in here and I'm just going to dispense it and mix it. And then I'm going to aspirate everything, all the contents from this well, so that the well becomes empty. And I'm going to move everything over here to the first well. So I don't know if you can see that. Let's move it maybe down here. And I'm putting my pipette tip right in the middle of that well. I'm leaving a space there for well 1 so I can put in a ladder. And I'm just going to slowly dispense the contents of sample 1 into well 2, or lane 2 rather. So the result is something like that. And students love this, and I love watching students do this. I wish you could be here to do it. Now, there's no easy way around this. I just gotta load up all 48 samples. I've done bigger gels. I've done 80, I've done 120. So 48 or 50 shouldn't take me too long. Okay, so this is what it looks like when the gel is fully loaded. You can tell that I have left a few of the lanes open. That's because we're going to put in the standard, the ladder. This is a Thermo Fisher ladder. It's 1 kb, so that means that it's got DNA fragments at specific sizes, and we're going to use that to infer the sizes of our fragments. Okay, ladders have been added. Now I'm going to put on the lid. You can see that it's going to make contact here with these terminals. Just like that. Okay, just ensuring good fit. Now the red, positive is here on this side, negative here. Does that make sense? We want our DNA to go this way. So yes, the negative electrode terminal is here, and it's going to be repelling DNA. Remember, DNA negatively charged, so our DNA should migrate in this direction. I'm going to turn it up to, let's see, how many volts do I want? 120, maybe something like 140. I'm going to start off with 400 milliamps, and we'll run it for, see this, let's run it for 40 minutes and see where we get. Okay, so here we go. Pushed it in. And what I love about an agarose gel is you can always tell when it's working because you can see bubbles. You see them? Maybe it's hard in this camera. I turned up the volts. Might be more readily see it. Boy, we've got 1 minute left. There's a lot of condensation on top. Go ahead and stop it early. Move this off. Oh, you see how it's migrated? These are dyes in the loading dye that we use, and they're a rough estimate for how far it's migrated. For instance, you see the yellow band here? That's about the 50 kilo or the 50 base pair mark. This is about the 500, and that's about the, I want to say the 3,000, 2,500, something like that. Let's load it up on the UV light box and see what we get. All right, it's the moment of truth. This is where I cry or shine. So there's just a button back here that I twist. It turns on the special light. Yeah! Oh, fantastic. Look at that. Oh, that's beautiful. Nice work, everyone.